So we need to show that sine 2 theta divided by 1 plus cosine of 2 theta is equivalent to tangent of theta. So let's begin our problem from the left hand side. We have sine 2 theta divided by 1 plus cosine 2 theta. Now there's a standard formula for expanding sine 2 theta. Here we have the trigonometric ratio of a multiple angle. So this becomes 2 times sine theta times cosine theta. And we also have cosine 2 theta. So cosine 2 theta is equals to 1 minus 2 times sine squared theta. And another form is cosine 2 theta equals to 2 cosine squared theta minus 1. Now, for the numerator part, that's fine. We can simply replace sine 2 theta with 2 times sine theta times cosine theta. We have a single formula. However, since cosine 2 theta has two forms here, we're going to choose one particular form such that this one gets cancelled out and the two terms in the denominator gets converted into a single term. Now, in order to cancel out one, we can use this particular formula. We can replace cosine 2 theta with 2 cosine squared theta minus 1. So we have 1 added to cosine 2 theta, which will become 2 times cosine squared theta minus 1. Now we can cancel out this 1. So we are left with 2 times sine theta multiplied to cosine theta divided by 2 times cosine squared theta. Now what we can do? We can factor out the 2 from the numerator and the denominator. We can also factor out 1 cosine theta from the numerator and the denominator. That leaves us with sine theta in the numerator, and in the denominator we have the cosine function, cosine theta. Now what's the ratio of sine over cosine? That's the tangent function. So we have tangent of theta, and this is exactly the expression on the right hand side. So therefore we have successfully showed that the left hand side is equals to the right hand side, hence proved.